In the density experiment, we determined the density of both an unknown liquid and an unknown solid. But the first thing we had to do was determine our true volume of our flask. So our flask that we used said 25 milliliters on it, but know that that is not the true volume of that flask. Ignore that 25 because we're going to use water to determine the true volume of that flask. The density of water will be given to you. It's important to use that to go between mass of water and volume of water. Anyway, so let's look at how we did this. So basically, you weigh the flask empty. Every time you weigh it, you weigh the flask with its stopper. So we may not say stopper every time, but we weigh the flask empty and we get its mass. And then we fill the entire thing with water. So we filled all the way up with water and we weighed it again. And so with the water, we have a mass. So now we can figure out how much water fit in there. So let's do that first. Okay, and when you do this, you need to pay attention to your sig fig rules. Notice that the digits have to extend, they extend to the place least far to the right. Well, both of these numbers extend to past the decimal, so this mass needs to extend to past the decimal. So this is our mass of water that fit into the flask. Once I have the mass of water that fit into the flask, I can figure out the volume of the flask by using the density. Be really careful when you do this because a lot of people that use this equation end up getting it upside down. They mess up their algebra somehow. So I'm just going to show it this way so you can make sure the units are canceling. So in this second step, this is where I'm using the density of water. And like I said, you'll be given a density of water up above. And so when I get my number here, this is 25 point. That's how much water fit in the flask. And therefore, that is the volume of the flask. Since the water filled the entire flask, the volume of the water and the volume of the flask are the same. Okay, so for the rest of the experiment, when I'm using that same flask, it's going to have the same mass, but I'm going to know its volume is the same 25.93 milliliters. Okay, so the same flask, I'm going to fill it with the unknown liquid, and it's going to take up all the space that the water did. So if I'm going to do the density of the liquid, I'm going to need the mass of the liquid divided by the volume of the liquid. Like I said, the volume of the liquid is the same as the volume of the flask. So I just need to figure out this mass of the liquid. Well, I can do that by figuring out, just basically looking at how much the flask weighed with the unknown liquid and subtracting off the flask. I'm going to abbreviate flask with just F. So this is the flask and the liquid. Subtract off the flask. And now I have my mass of my unknown liquid, and I can take that and plug it in to that place. And I notice I have 4 sig figs still. And the units are grams per milliliter.